Alright, this is my second video on long division of polynomials. So I'm going to do a little bit more complex of a problem, something that you might see a little bit different. So if you haven't seen the first one, I want to watch that one first. First thing we're going to do, we're dividing by x squared minus x plus 1. So I'm going to start with that on the outside, x squared minus x plus 1. And we are doing long division. When I write my polynomial that I'm going to put on the inside here, I'm going to go from my highest power of the x to the lowest, even all of them that aren't showing. So we go from x to the fourth to x squared. You should notice x cubed doesn't appear, but I'm going to make it show up down here. So we're going to have x to the fourth. Next would be x cubed, but since it doesn't appear, what I'm going to do is I'm going to put plus 0 x cubed. I'm going to do that. It's kind of a placeholder to make sure I do everything nice and neat so I don't miss anything. Plus 2x squared minus x plus 5. We're going to go through this process, and this process keeps repeating until you finish the entire problem. So you take the first term on the inside, first term on the outside. So I'm going to have x to the fourth divided by x squared. I had 4 x's available, I took 2 away, that leaves me with x squared. So I'm going to write that, line it up top with my other x squared. After we do the division, you write it up top. We're going to take this x squared and we're going to multiply it through all of these terms, not just the first one, all of them. So we're going to do x squared times x squared is x to the fourth. X squared times a negative x is a negative x cubed. And x squared times 1 is just a positive x squared. So after you write your term and you distribute through, what we're going to do is we're going to subtract these off. So we're subtracting every single term here. So this becomes negative. This second term is positive. Third term is now negative. So I have an x to the fourth minus x to the fourth. That's 0. A 0x cubed plus an x cubed. That's a 1x cubed. A 2x squared minus an x squared is a 1x squared. And you notice the rest of these terms, there's nothing similar being subtracted, so they just come straight down. Minus x plus 5. We're just going to repeat this process now. So we have 1x cubed, first term. So 1x cubed divided by x squared. Have 3 x's available, take 2 away. You get 1x. So I'm going to have a plus 1x, that's positive. I take just the term I wrote down, so we don't care about the x squared anymore. We're going to take the 1x, distribute it through. So x times x squared is x cubed. X times negative x is a negative x squared. And x times 1 is just a positive x. We're going to subtract off what I just wrote down. So all pieces are being subtracted, so all signs are going to change. This now becomes negative. This is now positive. This is now negative. X cubed minus x cubed, that's 0. X squared plus x squared is 2x squared. And negative x minus x, negative 2x. And that 5 is just going to come down. We're going to repeat this process again. So we're going to take the first term. So we have 2x squared divided by x squared. So I had an x squared, take away an x squared, so those divide out. So all we're left with is a 2 there. That's a positive 2. So we're going to put plus 2 here. We're going to take the term we just wrote, the 2, multiply it through. 2 times x squared is 2x squared. 2 times negative x is a negative 2x. And 2 times 1 is 2. We're going to subtract all these terms off. So we subtract here, we subtract there, that becomes positive. Subtract there. 2x squared minus 2x squared is 0. A negative 2x plus a 2x, that's also 0. 5 minus 2, you get 3. Now we could try and divide again. Another way that you'll know you're done is I went from x squared to x, and now I'm down to my constant. Once you get down to your constant up here on your answer, that's also a sign that you know you're done. So this is actually going to be my remainder. So my answer here is going to be x squared plus 1x plus 2 with a remainder of 3. That would be my answer for this division problem.